Hey guys, I think I'm here. Um, oh, bit tired. Should have got another cup of tea, but I didn't. Anyway, what's everyone up to? I've just put 2 bolts in the Bright Ericsson hot air engine. That's what I've done tonight. Um, 2 or 4. I'll put the other 4 or 2 in tomorrow night and finish that video and put it out. So it's only really the 4 bolts to go back in now. Bit tired. It's been a big day at work. I go to work tomorrow again, which is a bit of a cow. But anyway, I'm a bit late logging into this because I had to go downstairs and put power on because someone's turned it off. But you get that. Peter's waiting for me. That seems a bit sort of pointless sort of exercise, but anyway. So I'm sort of looking at this. Wondering what on earth we're going to do. There's projects. There's always projects. I've sort of been having a bit of a go, to be honest, on this Bright Ericsson hot air engine. That's starting to come together. So we'll have a look at that tomorrow night. But because of that, there's no other real progress on other projects. I've got things I need to do. We need to have a look at the Glenray timber fist plate. We did one last year, which was probably way too complicated. It was quite nice, but a bit much maybe. We need to do some other brass plates. To wait for this to reload by the look of it. There we go. Probably should do something with that low angle block plane or the low angle scrub plane or whatever you want to call it. What else? There's things we should do to the donation box. I haven't really thought about that. There's things I should do for the launch lathe. That's not probably going to happen either. I haven't thought about this particularly well. I look very scruffy. I did wash my hands, which is a pretty good effort, to be honest. I could do with some sleep if we're going to go there. What else? Spontaneity can be fun, yeah. Okay, well, maybe steam engine project, because we don't have enough of those. Muncaster's engine, because the book's right here on the bench. Right. This is Muncaster's book. Right, this little engine on the front. Henry Muncaster wrote for Model Engineer for many years. This book was published as a sort of some of his articles, or some of the more interesting articles that he wrote on engines. I've had this book for years. I think it's out of print now. But Muncaster, some very good engines. There's an introduction to pattern making. Moulding and pouring, and hints on machining bits and pieces. And a lot of mostly fairly terrible drawings. Oh, look at that. So I made a start at this. Whoa, I'm going to turn that on. I'm not sure. Is that better? That's probably better. I made a start on this engine some time ago. But because there's about 5 drawings for different engines of a similar size that have the same parts in them. Hey, Randy. You've got to look on a different drawing sometimes for the right bits. I'm not sure what I want for launch without going down a rabbit hole, James, of actually thinking about projects that I probably should finish. I'm not sure I want to go there. Anyway, let's share the screen. You'll get the blue screen of death here, I think. Or whatever it is. My glasses are very dirty. There's my phone. I'm not going to answer that right now. So this is where I got to with this. This is quite a pretty engine. It's the thing about Muncaster's engines as compared to some of the others is that Muncaster didn't design toy steam engines. He designed proper industrial machines. Proper industrial machines to industry specifications and cutting edge steam engines, because this was written, this article was written, and the book was designed 1905, something like that. Have a look here. First published 1912, this book. But I think that they were well and truly back issues of Model Engineer by then. So Looking at this, it needs a crankshaft is what it needs. We've only got a solid shaft through here. We've set it all out properly. There's our flywheel there on that tab, and our base, and the big cast column on the side, piston and rod, and the round column on the other side, and the bottom cover, piston rod gland, crankshaft, bearing brasses. So if we start here on the crankshaft, we've only got to change this and refresh the assembly drawing, and it'll refresh in the assembly. But we need some information before we do that. And I'm going to take my glasses off here because I can't see a thing. And back to back on this 1 5/16. And according to this, it's 3/4 inch throw. It's 9/16 between the cheeks. An 1 5/16 overall. That should be pretty straightforward. If we draw a picture, click here where it says front up here. My little mouse is a bit of a pain, and I'm sorry, guys. I'm going to draw a sketch on this end, or on the centre there. And a circle and a construction line. And 1.5 inches is our throw. Now we can draw another circle there. If we get rid of the construction line, we can draw another circle here where that intersects. And we'll call that 1/2 inch. We're going to do this way. What happened there? Don't know. This might be already set up, I think, for... So there's our centres. The crank webs, there's a picture, right, of how to fabricate up a balanced crank web. We're going to try something like that. Must be big enough to go. We'll draw another circle. That looks about right. 2.125, let's do 2 1/8, let's call it that. Not quite big enough. This measurement here, we can just drag that around where we like. 2.25 we're going to try. That looks better. And he's drawn a line down here, something like this. It doesn't matter much what it is. And we could work out the balance if we wanted to, but that looks reasonable there. I think that we need to put a radius on here. Center point arc. We put a radius there like that. And we can click this button here, which is transform. can move that round like that. Zoom out, we can probably get that pretty close. Ideally, we want to trim. Let's do this a different way. Ideally, we want a tangent off here. Let's put this down here, like this, and select tangent. And that fixes that. That's not bad. Zoom that out. Or what we might do is click in for normal. That reverses it for us, which wasn't helpful. But we'll live with that. And we'll extend that line. So the X key, send this one back up to here. And this one down to there. And then the trim, which is the M tool. Something like this, and mirror it on this line here. We'll turn yellow and we'll mirror it, and we'll put this line in. Then we can trim this one out. And that's sort of what his balance crank looks like, maybe. They're crickets, James. Cicadas or crickets. Yes, we've got lots of those. Now, if we extrude this, make a new piece on there and extrude it. It's 1 5/16. So that's what's 1/2 inch and 5/16. It's 1/2 inch and 5/32 is 1932. Is that right? I think so. And there's probably even a better way to do that. If we delete that, and we'll say that it's, have a look here at the mud map. It's 5/16 and 9/16 wide. Nine 16th is 7/16 and 5/16, 7 and 5s. 12/16 is 3/4 of an inch. So 1/2 of 3/4 of an inch is 3/8. So if we just make that 3/8, like so, and then put a starting offset of it, which is 932. That puts that in the right place. And there's a new item. So we can mirror that. And use the mirror. Mirror plane is this one. Puts another one on. We can merge it all together. And we can extrude basically this side of this piece of this sketch. Probably we can't. We need to put a sketch on there. So if we put sketch on here, and we use the project or the use tool and collect that, and extrude that, reverse the direction, and it's inch and 5/16, 1.3125. Add that in, click OK. Except we've moved something. What did we do there? We can edit that back easy, but something's changed. 1.3125. There we go. So we've got this bit in the middle. The easiest way is to put a sketch on here. And use the use or project key button, which I use a lot. Use those. And also that one probably, and that one. And then extrude that, which is that shape. Remove it. And make it symmetrical so it sticks out both sides. And there we go, it's a crankshaft. Very cool. A crankshaft probably wants a key on it. But let's have a look and see. All you see is me. Why is that so? Don't know. It disappeared. Anyway, I've got a crank. And obviously I'm in a huge... Now, not much of a crank. It needs a little bit of refinement. Because it didn't work. I'm going to measure this while I'm here. There's a radius on there. So we need to find that radius before when we put it back in, or we'll have some interference. Now, this is fastened somehow, Revolute for. Is that the right one? That's the correct one. So let's edit that. Let's move it from the center of the crankshaft to there. That's not how we want to do it. That's still not quite right. But what we want to do and find this. Not there. Let's just get rid of that. We'll get this back here out of the way, and then we'll set it up properly. So a new revolute, mate, so that it turns on there. Is that right? No, that's not right. It's this one here. See, I'm a bit sort of, I really appreciate people in the chat because it gives me someone to talk to. What we really want to do is set this up here on this edge of the bearing. Interesting. Why won't it do that? It's a split bearing, of course. What a revolute, mate, off there, off that radius. And that's not it. Why is it so? Let's try again. It doesn't like me very much tonight. I think we're going to live with that and probably just offset it. That's a bit terrible. But in the Y direction. It doesn't work. Let's get this out here so we can see it. We can skid it out because we've got split bearings. We need to find a center that we can work on. And probably the best way is to put a mate in there first. And that's easy, see? If we put a mate there, on the origin entity there, and click OK. We've got a mate there permanently. And now we can put a Revolute mate connector between this one here and this one here. It's not quite right because we haven't allowed the thickness of the bearing. And the thickness of the bearing is 13/16, so we can certainly offset that. 13/16, like all oldie worldy measurements. So there we go. The crank's in place. Not quite right, is it? This works here, but this one doesn't. So we've got a gap there. If we measure that between there and there, which axis is that? In inches. That's the y-axis, is 107 thou. So what we're saying is that this crank is 107 thou too narrow. You take care, James. I'm pretty good at talking to myself. That's kind of all we're here for. So look at the left here and see if it's actually offset. It is. But these need to be a little bit thicker. And it's 53 thou, something like that on each one. And have a look. Let's extrude 2. We'll edit that. $428 thou, is that right? 0.428. Let's have a look at that. Something's not quite right because it didn't readjust itself. It should have moved that way. Let's have a look here. This says 13/16. Is that what it says? It's very small print. Definitely says it's 13/16. Let's have a look here. This says 750, so that's why we've stuffed that up. Let's do it again. 0.75. There we go, fix that. Almost fixed it. Why is that so complicated? Have a look at this. We're going to measure and tape out again and measure between there. And there. Inch and 7/16, 0.1483. Why is that so? Okay. Let's go back to the start and try again. We're getting nowhere fast here. Let's measure this distance. This distance. We're out. Nearly 1/16 of an inch. So extrude 3, extrude 2. Edit that. Inch and 7/16 we said. Half inch is 8/16. It's 1632. And 732 is 2332. You gotta love fractions. And it looks nothing like it should look. Not even close. Are we ready to give up yet? $23.32 mustn't be right. Inch and 7/16. Inch is half inch is 8/16. A half of 1 inch is 8/16. Half of 7/16 is 732. So 16 and 4 and 3 is 2332. Let's do this differently. If we do that and put that in there, how does that look? See, it fits. Very close it fits. It does fit because we're over this one a bit and we're under this one. So that's right. We got that measurement right. Leanne, we're not doing very much, to be honest, darling. We're fuddling about is what we're doing. I've come into this without any thoughts about it all day. If we do it that way, and then we delete some of these because we don't need any of these. Don't work anyway. And delete that. Delete that. Delete that. Delete that. There we go. Now, looking at this, the distance between there and there, according to this drawing, should be 9/16 of an inch. Let's put a sketch on this plane. We'll start here with a center point rectangle right on here. And we'll go across here 9/16 because we can put a fraction in. Another one doesn't really matter. And then if we extrude that, remove it, symmetrical, move scopes that. It's going to need to be a bit more than that. That should have fixed it. Now, rather than go blind, we can go up to face. And we can select this face here. And that goes just right. We go second end position and we can go up to face again. We can go to this face. And that puts the crank part in here. If we click add, and then emerge scopes that, let's put that in there nicely, see? Now, new sketch on this plane. And probably the project tool. There. And extrude that, remove it, symmetrical, so it goes right through. And merge scope is that. Which doesn't work because it's in red. Let's try that. There we go, look at that. And then we could go Boolean union, add that and that and that and that. Click OK, and we've got it all in one piece. And if we have look back at our assembly, it's completely missing because we've pretty well got a new piece. Now, if we look at this here, there's our problem because this mate connector 1, let's edit that. That's all very well, but it's there and not on the outside. So we click move. And now X, how much is it? I guess we should determine this before we do anything. We should determine this radius. Bearing brasses. We'll open that and we'll have a look. This radius here is fillet 10. If we click edit, it's 1/16 of an inch. So if we come back here to our assembly and back here to our mate, and we edit that up, move it sixteenth of an inch. Wrong way. Wrong way again. Wrong way. Negative 16th. Not winning there. I don't know why that is. Don't really get that. Let's put it there. We're going to have to come back to the bearing brass and have another look. But what we want is this offset between this and this. So maybe we should just measure that between this and this. It's actually Y, and the Y direction is 0.44 inches, which is about what I got. So even though it's a 16th radius, that's actually the distance, offset distance there. Let's have a look. What's happening in your neck of the woods, Dan? Is it still raining? Well, that should be right. That should be the right place for a mate connector. I only see one problem with this. It's on the wrong end. Can we guess it? Let's insert the crankshaft. There you go. Because they're both on the same origin point, everything adds up nicely. More or less. What we've got is a gap in this one. So there's a gap there. No gap there. Now we're talking to it. I think we've got it. A short but loud thunderstorm. Sunshine on the Gold Coast. Bundaberg is flooded. Out west is a bit flooded. We had a lot of rain last night, but can we sneak across here and measure this? 438 is 7/16. Of course, it's closed that. I don't know. I'm about ready to give up on that. I think we fluked it, but that's all we got. Sorry, guys. And we know it lined up there. So what have we done there? Let's find it up. Let's reverse it. I'm not feeling it tonight. I think we should just talk about other stuff. Not worry too much about CAD. Anyway, it's in the right spot. If we animate this, we've got the crankshaft working. There we go. Hey, Mark. This is Mancaster's engine. Mancaster's 1.5 by 1.5 inch vertical. It's not even a project enough to be called a project. Let's fasten this to this. But it is a CAD project. Put that there like that on the end. We're going to offset that just for looks. Once we work out what we're going to offset this, that one. And now if we animate that one, move the flywheel too. So we have a crankshaft. That's where we're at with that. I guess that was worth the trouble. That took me an hour that I really wasn't thinking about things. That mate connector looks a bit ugly when you can hide that though. It's still showing the animation there. So I don't know, I've got to get my head around this again if I'm going to do any work on it. I haven't messed with it for a while. And I'm not sure I'm going to mess with it anymore tonight. But it's quite a pretty engine. Anyway, let's go back to the talking head and just have a talk, because honestly, CAD's not doing it for me at the moment. Anyway, here I am. Projects. There's a lot of stuff to talk about tomorrow night. You won't see my Bay Peacock engine because my mate Phil took it with him to get it sandblasted. So that's something you won't see. But we did get it free with a lot of hard work and desperation. And we'll get it sandblasted and get it back here and get some undercoat on it and start thinking about boring it out and putting a sleeve in it. See how that goes. We've got electricity tonight, which is really nice down the shed. We didn't have any last night as it rained, like it bucketed down for hours. I've got to go to work tomorrow. I'm not that enthusiastic about it. I'll be fine. I'll get there. I'll be fine. Work goes pretty quick once I'm into it, but getting there in the morning's a bit difficult, especially if it's raining. Don't know what else really. I'm feel like you're probably going up to the kitchen having something to eat. I had a slice of toast before live stream, so I've sort of had something, but a cup of tea would be very nice. Clean up a bit because there's dishes in the sink and so forth from the boys being here today. Is cast iron the best idea for a cylinder sleeve? I believe so. I believe so. Same expansion coefficient for a start. That's kind of good. So it means that when the cylinder gets hot, it's not going to leak or get loose, or it's not going to get tight and crack something. And the right cylinder coefficient for the piston and rings so that they move in and out properly. And it's something that you can put a pretty nice finish on. So it's also something that's fairly easy to machine with a good finish. What I'm probably going to do is take all the studs out. Famous last words. So I've got some of them out. And mount it up on the faceplate. Set it up pretty well on center with the indicator. And bolt it down pretty good. And bore it out. Then get a new piece of cast iron. I've got an old piece of cast iron which will work very nicely. It's a diesel engine cylinder liner, wet liner from old diesel engine single. Exactly the right size. So, and it's got plenty of meat on it and a flange on the top. I don't think it'll be thin and delicate. I'm expecting it to be probably 3/16 or a 1/4 inch wall. I think it needs to be that much. Got about 1/4 inch to 5/16 wall. I think I'll probably in cast iron. I think it'd be pretty nice down to about 1/8. But I'll get that right, and then I'll make it. I'll either attempt to shrink fit it, which may or may not work, or I'll make it a good, decent 1 thou, whatever, 1.5 thou, 1 thou press fit. Push it in with the shoulder on one end, so the cover holds it in tight, and couple of little breakers in the top as a Scotch key, just to hold it in place to stop it turning. And I don't think it'll move much. I think it'd be a very good job. And we can port it and so forth there, and we're not going to get too much leak or blow by or anything else. And then the back valve face, I really don't know what to do about that. Look, Dan's got, and we'll have a look at that tomorrow night. There's another engine down here on the bench that needs a sleeve. Probably doesn't need a sleeve. It probably wants to hone through it and say forget it. But he says it needs a sleeve, and he'd like to do it. And he's gone and bought a sleeve that's about 1/8 inch thick or something like that. Just a straight sleeve. I don't know how he's going to retain it or anything else, or what he's going to do, or whether he just thinks he's going to shrink it in. He might get it close enough, but it's a big sleeve and it's a big bore. And my experience with these things is that getting that shrink in there is going to be, and stay round, is going to be almost impossible. So I don't like that much, to be honest. Probably you could put a couple of little or something just outside the sleeve and counterbore them, and use the counterbore to retain them with a screw. Like, screw them down, 2 each end or something, 3 each end. That would probably be a very good repair. But I'm going to put a whacking big sleeve in this because really I'm just going to take it out till it cleans up. or a bit bigger, and machine the sleeve to match. But honestly, it needs a bit out of it because it's been full of water for some considerable number of years. So probably 500. Probably it's been full of water for at least 80 or 100 years. It's been that long since the cylinder cover blew. But we'll have a look at all that tomorrow night. I'm going to go from this platform anyway. Thanks for tuning in. I don't know if we did very much, to be honest. I had a bit of a play with CAD, which is the first time for a week. I need to sit down and do some things, but at this point, I'm sort of spending my days doing other things and I forget about it. But good to catch up with you all. I'm going to tune out. I'll be in Discord in a minute. I'm going to go and put this in the computer in the car and probably drive up the kitchen and lock up here and go and get a cup of tea and a cookie or something. Sounds good. Anyway, I'm out, guys. Thanks, and be kind to each other.